Okay, ready to start? Okay, so we got this recorded too. So today we will go over options available, the scores for, and the PDF of your answer sheet is in your Canvas gradebook. So if you go into Canvas gradebook and click on the score, it should pull up that PDF. So then you can review which questions you missed, which one you got right. If it's a purple color, it means you got partial credit on it. And what we will do with that, there were some good results. I think the test had 30 questions. 9 people got 28 correct. 2 people got 29 correct, and 1 person got 30 correct. So I based the total out of 28 questions. So your percentage is based on 28 questions, not 30 questions, first of all. Secondly, you are able to review the exams. I've got copies of them here. You can do it during our work session. So like after the lecture today, if you wanted to, you could get a copy of that. I have to ask that you work on them here in class because you can't take the questions with the exams, can't go out. They're used for the entire college. So, but you can work on them, and you can do you can do a test correction for half the points back. So if you miss something, what I want with the test correction is for you to, first of all, figure out what the correct answer is. You can work with other people in here, however you want, but work with that to and so there's 2 parts: is get me the correct answer, and maybe if you can ascertain why you missed it. Maybe it was a guess, maybe it was a calculation error or something. Then you can get half the points back. Okay, and you'll just do that on a blank sheet of paper. You'll list the number, give me an explanation of how you got to the correct answer, why you think you got it wrong, and that's good. And then I'll go through and I'll review those, and get you back half those points. So that's one thing to do. Additionally, I do have an online exam I could give you if you wanted to do a complete retake. But what I ask is that you go through and review do the test corrections first, because that's the first. The online test is a more type question. It's not multiple choice, so it's typically harder. But then I'm going to give you another option that typically helps, which will actually reduce the weight of the exam itself. So first of all, I'll do test corrections, and everybody certainly can get a passing grade, and maybe up to, usually if you'll do this, you do the test corrections and this next project, you'll still be at a B or an A. The second part, well, I guess before I go to this, the other thing I'm going to do is I'm going to drop 1 chapter score. So if you're missing one, that could be it. If you aren't missing any of them, so if you do them all, that means that one of them would be extra credit. So 30 extra points, 3%. So it's helpful. But also you could either drop a previous one or drop a future one, and it won't hurt you. Or if you do them all, you get that extra credit. Secondly, what we're doing today on Venn diagrams, I have a worksheet. So you also will have a choice today whether to just complete the worksheet for the 30 points for the quiz and the homework, or you could do the quiz and the homework online, whichever you prefer. But you'll see, we'll do some of this. We'll go through some examples with this little worksheet together, and it's an option that you could just basically finish it up and you'll be good. Secondly, or thirdly, or whateverly, right? There's a course projects available. This is an option. It's not a requirement. But if you take this option, it's about 20% of the grade now goes to the project, and generally it would replace a lower test score. So the test scores are about 30% of the grade. This is 20%, so it would replace most of one of the exams. And if you follow through with the project instructions, you'll earn all the points. So you'll have 100% on it. There's really just there's these details. I'm flexible on this, but basically, it's the project. I call it the math of blank. You fill in the blank. What I'd like you to do is to choose a topic of your that you're interested in, either maybe what you work in, maybe what you a hobby of yours, maybe some schooling that you're doing. So I'm going to give you some examples of what's been done, but it's very open. You can do the math of baseball, the math of, if you're into sports, it could be the math of any particular sport. And you don't have to get too deep. It's not like all the math of baseball. It's the math of one aspect, like maybe the mathematics of hitting a home run ball. And you'll see that has a the ball goes up and it follows a mathematical path. So how far does it have to be? And you can look up things like on YouTube or TikTok or any place. They'll have little lectures on the math of that. I've seen students use it. Your job is to summarize what you find, and hopefully relate it to it's something that you're interested in, right? So there's two parts. You'll write a summary, about a 1.5 to 2 pages, double space, so it's not real long, but so a written component where you summarize it, and an oral presentation. Don't get too stressed out. Does that mean I have to come up and give a speech in front of everybody? No. You can record it and just submit it to me where I'll review it. You could make arrangements with me to present your topic to me. It's a 4 to 6 minutes, so it's not real long. I've even had people who come and talk with me about it, and I says, all this information you gave me, was this good enough for a presentation? You're done. They said, well, I still want to do a presentation. I want to form, and you can record it. Use a cell phone to take a video of it. You can upload it to a service like YouTube or something, or you can just submit it to me through Canvas. I'll view that, and again with that, so there's and basically it's just two things. You need to be able to speak about math, explaining it, and write about it. And it's the same topic. It's not two separate things. It's the same thing. I suppose you could even read your summary if you've written it up, but it'll probably be more interesting if you just kind of explain it. But what I want you to see is that there is math involved in things that you're already doing. And for some of you, you're going to see it's actually probably pretty easy. So I'm going to show you some of the projects that have been done in previous semesters. Actually, I won't show them all to you, but I'll show you where they are. So after the midterm exam, there's this course projects that's available to you. There's some previous projects, Math of Islam. I think these are videos actually. If you click on them, you'll see the student presenting, and I got their permission. If you do a full, if you do a nice one, I might ask, do you mind if I share this with a future class? Math in Nature. Again, these people have said that they could be shared. There's this one I think this one's just a PowerPoint that they submitted. Math of Blackjack, How to Win. So this is card counting. I've had a couple of these done, some from students who just read about it and practiced it. I had a student who actually worked for the casino, and they trained him in card counting so that he could catch people who were card counting. Now, card counting is not illegal, but casinos don't like it. And so they train people to watch for it, and they say, hey, that guy is probably card counting. They'll ask that person to leave because they're winning too much. So it's possible, and that's what his job was, is to watch the card tables and try to spot people who he thought was using a card counting technique, and then they would ask that person to leave because they were winning too much. But he brought a nice perspective. I can't remember whose project this was, but you could do it. Then there's some other ones in here. I'm just going to share one. Bartending. This was kind of interesting. I had several bartenders, and their mathematics was, how do you tell when somebody's had too many drinks that you have to cut them off? So it was based on, and they would have to size them up. How heavy do you think that person is? And this sort of stuff. And I've served of this many, and on how they're acting. So anyway, it was kind of, that was what they did for a living. So they brought that in there. This one I really particularly like because I used to have a Jeep Wrangler myself. This student did a presentation on mathematics of jeeping, and once it loads up here we are. So you can see this is his Jeep. He's got it raised. He's got it ready for really extreme off-roading. When I took mine off-road, the most I would do is a gravel road. I considered that off-roading, but he does some pretty extreme. So he did and it takes a little bit to load. Last time it was a little bit faster. But anyway, he went through and he shows you there's angles involved when you do these things. You've got to get the angles right. The weekend before he gave his presentation, he added one little slide because he went out with his friend, and his friend didn't get the angles right and broke a drive shaft or something. So they had to have, basically, he towed him out. But his worked out pretty good. And again, most of this is pictures of what he's done. Here we go. He's showing the geometry, where everything you have to do. He explained it, steering box and everything, and you can see that he can get at pretty extreme angles. What you can do when you have your angles right, the tools that he used, make sure the angles were right, and if you get the correct drive shaft angles, it all works good. But his buddy who didn't, it broke, and so he can show his buddy didn't get it quite right, so they had to tow him out, and hopefully he helped them fix it. But he just, he was able to get an example of something not working as well. So if you don't get the math right, again, this was something that he did and took to the extreme, and so it was really easy for him to put this presentation together. That's what I'm looking. You don't have to go make up something or find something that you don't know anything about. I'll bet you do something that has math in it, some kind of presentation. If you're not sure, talk to me about it. And I've had students who will go through, and this is Derek here, on a very extreme thing. Like I said, I would never do this with my Jeep, but mine wasn't ready for this kind of stuff. But he did that. So mathematics of something. In your job, you're probably doing some math. Talk with me about it. You'll find things. I've had students who will sort of apologize because they keep changing their topic. And I says, each time you change your topic, you're having to do some more research, and you've maybe researched 3 or 4 things. I'm getting more bang for the buck out of this thing than, and that's kind of what it's about. It's just for you to see that you're already doing math in something you do. And again, it doesn't have to be all the formulas and stuff behind it. You can just see the results of it. So again, if you're in sports, you do it. If you walk up and down stairs, there's a lot of mathematics. I've done robotics, and if you try to program a robot to climb stairs, there's a lot of math involved. So think about you walking upstairs. There's things involved. Again, when I first started doing this, I had football players coming to me who needed 1 extra credit. Says, here's your project. Tell me the math of being a lineman, the math of being a field goal kicker. What kind of math do you use? And they did it. Okay, so that can get you 20%. That can replace 20%. It's a sort of it's not extra credit, it's alternative credit. But if you do this, it shouldn't take too much time, but I believe it'll be helpful to you, and it'll be helpful to your grade. It replaces 20%. Either this, and again, I put it where it does the best good. So if you're doing well on this exam, maybe you don't have to worry about the next exam so much. If you want to sort of replace this exam, you can do that. Again, you also have the corrections that you can do that you'll get half the points back. Okay, but by doing those, everyone's still in the B to A range. It's all possible. And then we just have 6 more sections, 6 more chapters to go through. Remember, one of these, and again, whichever one you don't do one, that will be the one that we call extra credit. If you do them all, then you get the extra credit. So it's all up to you. The project there's no set due date, but it's basically by the end of class. So I've had some people wait until they take the final, and if they didn't do so well on the final, maybe they do the project then. I wouldn't suggest that. I'd say go ahead and do it earlier, but it can be done that way too, because the presentation can be just a video upload, right? You can even do it later. Okay. Any questions? Good shape. Okay. So we're going to then take a look. We're going to start in chapter 7. So today we'll spend maybe the next 45 minutes talking about sets and Venn diagrams. I've got a worksheet, but I don't want to give this to you yet because I want to talk about some of the symbols, and then we'll work through some of this worksheet, a lot of it, together. Okay. Um, and for those of you who are maybe listening to this on recording, um, if you come in here, the worksheets that I have printed out, they're all available here. So there's a link to the worksheets themselves. There's even, and for those of you, there's the solutions to the worksheets. So you're going to see, I've also given you the answers. So as we'll work a few together, my goal is that you try it and then you check the answer. If you didn't get it right, maybe see why. Oh, now I see what I should have done. Or, I guess, you could just go in and copy it all. Maybe you learn a little bit. Sometimes we do learn some things from copying. But again, the goal is that you just get some experience working with what Venn diagrams are, a little bit into logic, and we'll do that. Okay. There's videos here that are more specific that I've used. I don't know if I did these or I think I did. So again, you can come back and look at these, but we will do some examples. It's sort of the old school paper and pencil, no computers needed today. And again, if you turn this in, you don't even have to do the section on chapter 7. You'll get the full 30 points for the quiz, 15 for the quiz, 15 for the homework, just by completing this. You'll see it's a little bit shorter, but if you want to, you could also do the online one. It's all up to you. But if you turn this in, you'll get the full points. Okay, so let's start with PowerPoint. And these are just going to be some concepts and ideas about sets and Venn diagrams. And then we'll get into the worksheet. But we're just going to introduce a few things. I'll skip over a lot of these. I used to do this in more depth, but this is from a previous book. We're just going to really look at Venn diagrams and sets and what sets are. So we're going to look at all those things, but we'll get to that in a moment. So first of all, what is a set? If I had a set of china, what would that look like? Would everything in this set of china, would everything be exactly the same? Would everything be different? How does it become a set? What if you have a set of china, or maybe tea or coffee? I guess you could do it, but usually it's for tea. What is similar about the things in that set?
They're all like, china. They're all dishes.
Okay, and typically, if it's called a set, it's got a similar pattern. Maybe it's got roses on it. Maybe it's got butterflies, but there's something similar about them. There'd be a teacup and a saucer, right? If you're real formal, you'd have to have those things. You'd have your teapot. You might have a creamer. You might have a sugar place, but they would look the similar because they'd have a similar pattern, but they yet would have some differences, different purposes, right? So that's what a set is it's a group of things that have something in common, but yet there could be differences. Okay, so a lot of what we're going to use as our sets are numbers, but they don't have to be numbers. They could be things. So first of all, we'll talk about the universal set. Put my marker here, got ahead of myself. And what we do with the universal set is we typically will represent that by a rectangle. So this is the universe. That's everything we're talking about. Let's talk about maybe motor vehicles. Okay. So that's everything that's a motor vehicle. Cars, trucks, motorcycles. Some of those scooters are maybe getting there. And a Venn diagram was invented by a guy named John Venn, who came up with these diagrams. What he did is he came up with a system where you had your universal set, and then you would do circles, and these circles would represent a set of something. So this set might be pickup trucks. I'll just do PU. And then you might have another circle that could overlap this. And maybe this would be red vehicles. So if we're doing that, let's see how intuitive this is. What would something be if I put it right here in the middle of these two sets?
A red pickup truck.
You got it. See? Very intuitive, right? It's both red and it's a pickup truck. Good. Yes, sir. Question or stretching? Okay. Now, what if I put something over here? What do you know about that thing?
Why it's not a red or pickup truck?
Exactly. It's out of the, it's not in either set. So we know more about what it's not than what it is. We know it's a motor vehicle because it's in the universal set. I suppose we could put something out here and then we'd say it's not a motor vehicle. So whether it's in the circle or out of the circle tells us whether it is something or it is not something. So this one, again, all we really know is it's not red and it's not a pickup truck, but we don't know. It could be a motorcycle, it could be a sedan. We know it's not red, so it could be blue, white. It could be a number of different things, but it's not red. Okay, so we only know what it's not mostly. Something over here, what do we know about it? We know it is a pickup truck, but we also know it's not.
Not red.
There we go. It's either in or it's out. And so there's going to be these overlapping things. Yes, sir.
And if there's a variable in the red, we know that it's red, but it's not a pickup truck.
There we go. Exactly. It could be a motorcycle, red motorcycle or red sedan.
I want to get out of the way.
Thank you. So excellent. We've got all these regions, and that's what we're going to be doing. Is we'll be doing it with 3 circles. So you'll see there's multiple regions, but we've got it. We're going to work through some things together and see how we can organize like a survey list of what's out there and be able to answer some questions from a particular listing of information that might be harder to do by using Venn diagrams. Okay, good. So you guys are already experts. So now here's a picture. This could be pickup trucks or whatever, but here's set A. Anything that is in set A is in the circle. Things that are not in set A are outside the circle, but in the rectangle if they are part of the universal set. Okay. We also have this concept of, get back, sort of not, of things that are not in A, and we use 2 different symbols we'll see in the worksheet. There's this little thing that's called a prime, and you'll see this if you take, if you ever went to math, they also use it for calculus, but this prime means, in this case, not in A. In the worksheet, they also use this little C to talk about the complement of A. So notice what's not in A would complement. It's the universe is either you're in A or you're not in A. If you have both of them, they complement each other. You're complete. Okay, so you'll see this in the worksheet, A complement. So not in A, or we could use the word the complement. Right, whatever would complete it. And just some notation, again, we don't do this in the worksheet, but you may see this in some of the homework. We write this that A complement or not the thing that's not an A, right? That we could write it as it's every X, it's everything. And this little bar here is just read such that. This is called set builder notation. So it just translates, that's what that bar means. You could almost, this makes it very formalized, but it's every element that is, X is an element. That's what that symbol means. It's a member. It's in the universe, but at the same time or and at the same time. It's not an
Not.
element. Good. Just, yeah, the line through means not. Not an element. Very intuitive, but at the same time, somebody did come up with this. And so we might be thinking differently, but it also very similar to what we got. So X is not in A, but it is in the universe. That's what a not A means. Okay. So nothing overly complicated, but since we'll be dealing with 3 sets, it can become very complicated. But again, we'll get there by working through it together. We can also have sets that are contained within another set. We call those a subset, right? Does that kind of make sense? Subgroup. So A is a subgroup of B, and we can use this symbol for subset. So it's a sort of a sideways U. The line underneath comes from the symbol for equals, just like we have less than or equal to, right? So it includes a possibility that A and B could be equal. They could be exactly the same thing. And in sets, we call things equal when they are exactly the same. So it's like me. You could call me Mike, or you could call me Michael, or you could call me Little Crow, or you could call me a lot of different things. But I'm still the same person, right? Same thing with the sets. When 2 sets are equal, you could call it A or B, but it's really the same thing. Okay. So we would use this symbol that says A could be the same as B, but it certainly has to be a subset, which means A cannot have more stuff than B has, because it has to be a subset. Everything in A has to be in B. B could have some extra stuff, but everything in A also has to be in B. So this picture kind of says it all, right? You can't have part of A coming out here. Nope, that's not allowed. A has to be totally contained in B. Okay. So this first one is the first one a subset, and it always reads from left to right. Is ABC a subset of ACD? Everything here, ABC, is ABC over here? It's missing the B. It's got a D here, but that doesn't help. It's missing the B. So this has something extra that this doesn't have. So it's not a subset. So we would use the not a subset. So that slash. Very good, because 1, 2, 3, 4 is all in one. Yeah. Now, they are also what we will call equal, because they're exactly the same, right? So we could have also used this symbol that they are equal, but they're certainly a subset. So good. Now we're going to introduce the concept of a proper subset. And a proper subset simply is, well, there's the answers. There we go. A proper subset means they can't be equal. So if they're equal, we could use either of those. But a proper subset does not allow them to be equal. Because think about it, if they are equal, they're really the same set. So a proper subset is really a sub of the other. The main set has more. Okay. If they're equal, then they're just equal. So, and again, I don't know why they make it a big deal. I wouldn't have made such a big deal. It's either a subset or it's not, right? You could leave it at that. But a proper subset, we use this symbol without the little line underneath, without the equal. So it does indicate that A is somehow smaller than B. B has something more than A, at least one thing. So that's a proper subset. Oops, I didn't want to do that. Get rid of it. Okay, so now we could use either just a subset or a proper subset in these. How about this first one? ABC. Notice they change it, ABCD. Is that good? Which one could we use? ABC. Is it a subset? It is a subset.
Yeah.
So actually we could use this one and is it a proper subset? Yes, because the second one has it has that extra D. So this is actually also a proper subset. So we could actually use both of these symbols. Remember, this one with the little line underneath means it could be equal, but doesn't have to be. So it's more inclusive. So we could use either of these. The second one is still a subset, but it's not a proper subset. So we could only use this one. We can't use the other one because it's not proper. They're equal. Okay. So for A, we could use both symbols. For B, we could only use the non-proper subset one. Very good. And again, this the curriculum has changed a bit, so this goes way back when this was actually this was one of the competencies of the course, to know the difference between a proper and a non-proper subset. Uh-oh, what happened? I ran out of slides. That must mean we're done. Okay. So, time to take a look at this. And again, you have an option here. You can complete these in place of Chapter 7. You could do Chapter 7. But if you follow along with this, you could do either one. If you follow along, you'll have half of it done. So, and all we're going to do is we're going to apply what we've been doing. And I'll show you, again, I've actually given you the answers. So notice down here, link to Venn diagram worksheet solutions. What you're going to see if you go into this, for one of the pages we do, I have you do some shading. The answers are here. Okay, again, the goal is that you kind of try it on your own and see what you get and see if you get back there. Second page, there's a page of this and answers are here. Some of these have multiple answers, so yours might be different, but those are in there. But what we're going to start with is, oh wait, I think I have these open already. Okay, yes, I do. Okay. So first of all, we'll start off with this. This is actually the last page. And the reason I did this one is you're not going to complete anything, but you might want to have this set aside. So if you want to, you can take it out and just kind of use it to kind of look at definitions. So what this one does, I forgot I could do this thing. What we can do here is, this is saying what does set A look like. And again, this is with only two sets, but it just means that only A is shaded. Notice there is an overlapping region, but this is everything in the circle of A is shaded. Okay, so it's just kind of getting you to visually see where these lines go. This is that A complement, which also, remember, in our slides was A prime. It's not in A. This is what's not in A. Well, it's now everything shaded that is outside the circle, right? So you're either in the circle or you're out the circle. Same thing with B, they're just showing that. Okay, so here's B, B is shaded. Here's B complement or not B. So everything except B is shaded. Okay. And we're going to be doing some things with 3 circles, but this is just it's not really an answer key, but it's just kind of definition. Now let's work, I don't think we talked about in the sets the union, so we're going to do that here. So if we have 2 sets and we take their union, that's what the U stands for. It means everything in both sets. Okay. We will use the word, and some of this we're going to get to when we get a little bit later into probabilities, so that's why this one sort of helps. We also use the word for this, the word or, A or B. A or B. Now, the thing with this is its logic. This or is different than how we use it in everyday speech. This is the inclusive or. Inclusive. So if I told you you could have chocolate or vanilla on your ice cream, what does that typically imply? Can you have both? Now, when we use the word or, you can have chocolate or vanilla. You have to make a choice. In logic, you don't. You could have the swirl cone with the chocolate vanilla. That was my favorite. Get a little bit of both, right? So, or this is the inclusive or, chocolate or vanilla or both. I'll take both, okay? So that's the inclusive or. And you can kind of see it's something that's an A or B or here. So it's sort of like the either or. It's an inclusive or. Typically in our language, when we use or, it's exclusive, one or the other. Then we have something called an intersection, which is an upside down U. I'll put that over here. This means intersection. Again, intersection. Sorry, I have to continue it there. And this is the exclusive and. So remember, this is going to be exclusive. Exclusive. So this would be A and B, as they're showing here. I guess I missed that part. But a lot of times you say chocolate and vanilla means you can have both, or you could have one or the other. So this is how we were thinking. So in everyday use, we use and kind of in a more generalized. But when we use it here, the and is exclusive. It has to be both A and B. It has to be only when you get both vanilla and chocolate does it count. So you have to be in both clubs. And so that's why only this sort of this middle section is shaded. The thing I can relate it to that does work with how we use language is when you wanted to go out when you were a kid. I grew up in the city. The only place for us to play was in the street, or at least that's all we chose. So we'd play our ball or whatever we were doing. And we loved to play in the intersection. My mom says, don't play in the intersection because that's where two streets cross and that's the busy part. But it's also the biggest part that's open for kids to play in. So that's where we always played, in the intersection, right? It's where the two streets cross. That's what we're doing. It's where the two sets cross over each other. That's the intersection. So if you grew up in the city and you were like me and you always played in the intersection, you know what that is. And you know when the cars come, get out of the way because they're not going to stop. And actually, we had a three-way intersection. So that intersection was a big area, a big open concrete to play on. We had a lot of fun in those days, but we also had to watch. We had to have one person watching for cars. So we got out of the way and none of us got killed. My dog wasn't so lucky when he got out and ran, and he didn't know good enough to get out of the way of the car. So that's what ended his life. What did we call him? Beauregard. My dad named him Beauregard. We called him. I can't remember what we called him, but we didn't call him Bogart. Something like that. Anyway, I digress. Okay. And again, you can have complements. So you can have the intersection, but the complement of the intersection, and notice the complement is the only, or the intersection is the only thing that's not shaded. Again, you may also see this as A intersect B with a prime, which means not. So watch for that. You're either, the not is sort of the negative, right? Positive and negative. So if you're into photography, the negatives are always backwards from what gets printed. So that's what the not is. And again, this is not something that you're going to do. It's just more of a resource as we go through things. So some other circles and stuff. Okay. Okay, that's good. So now let's come back up here, and we're just going to do a few of our own. Yes, sir.
What about the if and only if
that's more advanced than we're going to need to do. So we'll talk about, if you're interested, we'll talk about some of these. Again, this might be something that you might want to do your project. I've actually had some people apply Venn diagrams to what they were doing. Like, it's great for biology, classifying things. You know, what is a mammal? A mammal has this, this, and this, and something, you know. But anyway, we're going to do more simple stuff. So we're not going to do all of this. So first we'll start with this, which should be pretty simple because this is what we just did, right? So what would I shade here for A union B? Yes, sir. Both of the circles. And you might do this as, okay, I'll shade A with one direction and one color. And then I'll shade B in a different direction with a different color. So yeah, you see A union B is everything, even the stuff that's in the intersection, but it also helps you see that the intersection is going to be where both of them are. So that helps you with the next one. What is A intersect B? It's just the middle part. It's where the two streets cross. Okay. And again, this helps. Again, by doing this, you're also, remember how the brain works. When you're using your writing utensil, that's your fingers. That part of the brain's up here. The mathematical, logical part of the brain is right next to it. So you're activating brain activity in the place where you need it. This is something new we didn't talk about, but this is taking set A and subtracting off B. So what might that look like? It's everything in A, but B is subtracted off. Anything that was in A that came from B is subtracted off. Yes, sir.
In all of A except for the intersection.
Okay. It's like the Cookie Monster came and took a bite out of A, right? So everything in A, but not what B, because B took that bite. It sort of subtracted it off. Okay, so it's used in some people will use it in their logic. It's not always, it's more complicated if you don't use it. You could do it with intersections and unions, but it would be more complicated. So subtraction is a very simpler way to do things. So I like having that. So far, so good? Okay, so it's a pretty simple one. We're going to get a little bit more complicated.
Wait, question?
Yes.
For the second one, what is that symbol again?
Intersect.
And
Intersection.
why is it, like, how come we're doing like so it's like the intersection? Like the opposite. That's supposed to be like the opposite of the first one.
Not quite the opposite, but it's union and intersection are connected because the intersection is more restrictive.
But you still have confusing because one's going like up and the one's going down. Not exactly like opposite.
Sure.
So that's kind of
Yeah. So this is, yeah, when it's up, that's the same thing as saying A or B. We could have just done it this way, but it's because it's a union, it has that idea of bringing everybody in. So it's everything. Intersection is A and B. So it's only people in both groups. So you might think of it A and B. So, there might be the group of people who work in a factory, but A might be the frontline workers in the factory, and B might be management in the factory. And some of those management may actually work on the front line as well, because they might be a crew chief, but they're management, but they're also a worker. And so you might have a meeting with everybody, but you also might have just a management meeting. And you might have just a management meeting with the frontline workers, not with the muckety mucks up, who don't know what they're doing because they're not working on that. So that's the idea. Yeah, it is restrictive, and it takes some getting used to. And it's just this was somebody's idea, right? And then it became, because they wrote the book, that's how it's done. But it might not fit with how we see things. And so that's a lot of what we're doing with math is we might have an understanding, we might have done it differently, and it makes more sense to us how we're doing it. I'm there with you. But then part of what we're learning is, well, this is how they did it, right? Different languages. I like have different things about gender. You know, Spanish, you have to a lot of times know the gender of the person you're talking about, whether you put an A on the end or not. I think Russian's the same way. Is it? That's one of the things I faced in Russian is when I was trying to learn it. Um, it's got some specific things that English doesn't have. We don't have to know the person's gender because we don't change the word, or sometimes it's helpful, but um, anyway, yeah. So that's good question. So let's clear this out. Now we're going to talk about what we'll be doing is using a Venn diagram, and these numbers in here are not the elements. So this 11 is not, it's just saying that there's 11 things inside that region, okay? This 5 is that there's 5 things, that not 5 is the element, but so forth, and 3, that there are 3 things in this particular region. So what can you tell me about these 3 things? What sets are they in? They're in all 3. Good. So they're A, B, C. How about this 5? There are 5 things that are only in A and B, not in C. Good. So that's what I was telling you about. You've got all these different regions. This region is in A and C, but not B, right? So if something was here, there's nothing there. I'll clear this stuff out. And that there's 14 things that are only in C, but not in B or A. Now, there's nothing out here, but if there was, what would this number represent?
It's like outside, it's not part of any of them.
Yeah, it's not in A, B, or C, but it's in the universe. And in this case, since there's nothing, it's a big 0. There's nothing that isn't in one of these. So we're going to ask this question: how many elements are in A? And one of the most natural, yes, sir.
11 plus 5 equals 16. That plus 3 equals 19. So I'd say 19 total elements in the A space.
Excellent. A lot of
So we add them by like a number.
yeah, it's everything that's in A. Oops, I don't want to do that. Come back here. So this is an A, these are in A, and these are in A. So it's 11 plus 5 plus 3, yeah, 19. You'll see this in some, if you do the online version. I don't think you'll see it in my worksheets, but they would ask this as in of A or number in A, and you list it as 19. So you'll see this little in stands for number. And that's pretty universal throughout. So if you take this, if you're in another course that does this sort of stuff, you'll see this. By the way, there is a course that basically this comes from. It's Philosophy 103. I think it's philosophy. I don't know how they abbreviate that, which is called Logic. And I've had students Logic. Oh, that's it. That maybe weren't as good in math, but they really like the logic. I do okay in math, but I really don't like logic. So for some reason, it's anyway. I don't hate it, but I don't. It's not my favorite subject. But that student really got into it, and she could do some pretty complicated logic stuff. So that's it. So how many elements are in A union B union C? How would we calculate that? We would add them all together. So good. 11 plus 3 plus 5. And it doesn't matter the order you go into, just make sure you get them all. And also make sure you don't count any of them twice, right? This 5 is in both A and B, but that doesn't mean we use it twice. So that would be 10 items. It's still only 5 items, but they have two characteristics. Okay. Yeah, just add them all together. And you'll get the answer there. rid of that. How about A intersect B intersect C?
Oh, where it's like.
Right.
Five plus. It has to be all three.
It has to be all three. Remember, it's an exclusive. It has to be all three. If it
Plus one.
well, is one in A?
No.
It's not.
5 plus 2.
Well, it's 5 in C.
Oh.
There's only one number that's in all three. That's the 3. So this one is the simplest of all because we don't have any calculation, but it's also, you have to just see the region, right? So that's the easiest one to answer because it's just there. How many elements are in A union C? Everything in A and everything in C. But again, we have to be sure that we're only counting everything one time. Get rid of some of this stuff.
17. Wait. No.
A union C is 11 plus 5 plus 3 plus 1 plus 14. Like 25, 30, 34. All right. B intersects C. B intersects C is this region, sort of like a football-shaped thing. We got to count both of these, right? 3 plus 1. No, yeah, the number in B intersects C is 3 plus 1, 4. And then the last one, which we'll do together, B minus C. So we're taking B minus C. It's everything in B except the Cookie Monster bites this out. So what is it going to be? 5 plus 7. It's just that the Venn diagram portion allows us to sort of visualize things, but we have to see the regions, and then the answers will be right there. Okay. Doing good with that? Makes sense? Let's do, now I've got some video, one of the videos does this 3-unit shading, but I'm going to ask you if you can just do, the assignment here says complete at least one from each row. So you only have to do 4 of these. Let's go ahead and do one of them together. I'll do whichever one you want, just to kind of let you see the process. Any suggestions, any requests? I could do the easy ones, or I could do the hard ones. Do a hard one. Remember, you also have the solution guide to this, so it's not like you could always take a look. So you're going to get this right either way. Let me see. How about number 7? Okay. And if you want to, you could look at the video. I did, I think, 2 in the previous class. So I recorded that and posted that already. So we will start off here. First of all, these don't have the rectangle around them, for the universe, but which we kind of need if we're going to do a, because I can see we've got a B naught, we've got a prime in there. So the first thing is we have to do order of operations. So we start inside the parentheses. Let's draw, and sometimes to actually do these, you need to draw them twice. What I'm going to do is draw and erase, because I have a nice little eraser on this thing, but it might not work well for you. So A intersect not B. So everything that's in A intersected with everything that's not in B. First, we need to label these, right? And I'll just do A, B, C. If you label it differently, your picture may look different, right? But we'll see. So I want everything in A that intersects whatever's not in B. Not in B is outside the B circle, right? And so everything outside the B circle but inside the A circle, let's see, what color should I, I'll just use the red, would be this. We're in A, but we don't get into the intersection with B. And again, if you really did this, it would be everything outside B crossing over what's in A. But does that make sense? So that's the first part. And now what we want to do is we want to take that and we want to union it with C. So union means sort of to add in everything else from C, right? And so I'll do this in a different color, even though it's going to be everything. I'll do green. So then I get to bring in all of C. So there's a little part of C already in here, but I get this part as well. And I get this part. So notice part of B gets brought in here, but that's because we're adding everything from C. And so when you're done, you could kind of make the shape. It's everything in A up here, everything in C, even the stuff in B that was not there before. This part never got added in, so we go to there, and then we get this kind of a weird shape, but that's what it's going to be. Okay, so this is the use of logic to see which regions are in there. Again, give a few of these a try. So we did one. If you do 3 more, you'll have this worksheet done. Again, you also have the solutions. So if it's helpful to take a look at a few, just give yourself the benefit of, learning something. Okay, so do 3 more of those. Down here, it's the reverse. So what kind of logic symbols would we use to describe these shadings? Again, you can't, since there are only two sets, a lot of these you could look up on that first sheet I gave to you. What does this first one look like? 13. Yes, sir. That's what's not shaded. So what must they have done at the end? To get the shaded part, they must have said not, right? A union B is the part that's not shaded. And then if we do yeah. And again, there's more than one way to put these, but here's one way. Or you could put the part, maybe you see, that's the other part is here, see, right? I said the shaded part, well, you could say, well, the white is shading because this was all gray, but however you see it. So the gray part, well, yeah, shaded area, the gray part, okay? So again, work through a few of these, and I think you'll be able to see ways of coming up with this. There's also the answer key. Again, the answer key has a way, but you might have a different way of describing the same thing that's correct. But a little bit of practice. And then we're going to finish up here. There's 3 of these to do, and what they are is they're like a survey or some information about 3 sets. There's here classes that are taking English, political science, or history. The middle one is about people who go on a wine tasting party, and they have 3 types of wine. Or there's number 3, which is trucks filled with peaches, and they're either early peaches, late peaches, or extra late peaches. We will do one of these together, and then your job will be to do the other two. So I'm going to show you a method that's very similar. It's basically counting through here. Which one do you want to do? 1, 2, or 3? Doesn't matter to me. 2. Okay, we'll do 2. Just to let you know, I did 3 with the other group, so if you want to, you could watch that part of the video and have it done, but I think you'll be fine. So the trick to this is, oops, I'm over here. Again, I don't have the rectangles drawn. So this is sort of the universe. We have the following list shows preferences for 102 people at a wine tasting party. And you kind of have to read through this, but there's 3 types of wine. There's a Spaniata, Ripple, and Boone's Farm. So we need to label our circles. So I'll label one as S, one as R for Ripple, and Boone's Farm as BF. And since we're doing this one, I get to tell you one of my funniest memories from my family. I hope well, it was long enough ago, I won't get my parents in trouble, but when we were kids, we'd go out for the holidays or whatever, usually rent a house at the beach. We did that, and oftentimes my mom liked to make spaghetti. So if you make this kind of Italian, but with Italians, they like to drink wine. So as kids, they would let us have a little bit of wine. And we had some, and this goes with this Boone's Farm. We had some Boone's Farm wine that we were drinking, and it had a funny sort of name. And we knew my younger brother, had had too many glasses of wine because it was called Tickled Pink. And he says, "Could I have some more of that pickled tink?" And when we said, "Oh, you're already pickled, though. You've had enough." And he was, a smaller guy. So anyway, I just remember that to this day. My little brother Robbie, "I want some more pickled tink." I said, "Oh, you've had too much, my young sir." So, anyway, so let's get on to this. The key part of, and this will help you, because I always did these backwards, and a student helped me see sort of the easier way. Where we want to start with, what we're going to do is label each of these regions with a number. And it's the best thing is to start in the center if you can. Where's the center? It's the people who like all 3 of the wines, right? So what number goes here in the middle? You got it, 93. Now everything else we're going to do is going to be a calculation. We're actually going to be subtracting off these 93 because they're in this place where they're in the three circles at the same. So next we do the ones that only liked 2 of them, or that liked 2 of them. So 96 people like Spaniata and Boone's. Spaniata and Boone's Farm would be sort of this football-shaped area. But notice 93 have already been accounted here. So how many are in this region? Not 96, but 96 minus 93. That's 3. We're going to put 3 here. Okay, because when we add these 2 together, that's the whole intersection of Spaniata and Boone's, yeah. So there's our 96 people. But if you put 96 here, then you got 96 and 93. We're already over the, we're getting pretty, that's counting everybody. So we took care of those guys. 94 like Ripple and Boone's. So we've got 93 there. So how many are in this little unmentioned region? 94 minus 93. There's 1 person who didn't like the Spaniata, right? Only liked the Boone's and the Ripple. Okay, so notice how we're going to be able to answer questions about these relatively easily. If you waited to try to answer questions about it by looking at this, it's very difficult. Okay, so we took care of those guys. And then 95 like Spaniata and Ripple. Spaniata and Ripple would be this football-shaped area. How many, sir?
2.
There we go. 95 minus 93. 2 are in that region. Excellent. Now, we've got 3 more pieces of information. 99 like Boone's Farm apple wine. not the pickled tink or tickled pink. So 99, but we don't put 99 in here because we've already counted these 93, 96, 97. So what goes in this circle here, 99 minus 97, 2. Very good. 2 go here. And then, so we took care of that. How many like Ripple? Ripple is here. How many? And so we got 96. But how many have we already counted? 93 plus 2 plus 1. That's 9. We've already counted 96. How many are in this region? 0. Nobody only liked Ripple. People who liked Ripple also liked at least one of the others. And finally, Spinata, 99. Again, we don't put the 99 here. But we have to figure out how many we've already got here. We've got 93, 96, 97, 98. So 99 minus 98, 1 person. Now we're not quite done yet. We have to find out if there was anybody who didn't like any of the wines, which could be possible, right? Maybe somebody's really a picky wine drinker. So what do we do to figure out if there's anybody out here? We have to add all these together and subtract it from 102. If we have 102, then everybody likes a wine. If we have more than 102, we made a mistake somewhere because we know there's only 102. And if we don't have 102, then we know that there was some that didn't like any of the wines. So let's see, got 93, 4, 5, 6, 7, 8, 9. It's 99. 102. If you add all of these together, we get 102. So that means there's nobody out here. So we'll put that 0. And now watch, we're going to be able to answer pretty much all of these questions without having to do much calculation. We might have to do a little bit of adding or something. So how many people prefer none of the 3? 0. See, no calculation. We did it. We already did all the calculation behind this. But if you tried to look at all this, it might be hard to do. How many prefer Spinata but not Ripple? Spinata but not Ripple. Good, it's these. So these 2 are in this 1 and the 3, but not the overlap. So there's 4. We did have to do a calculation, but it was easier to do than trying to figure it out. Yes, sir.
I thought you also have to count. Yeah, sorry.
Okay, good. So just 4, because we know they have to be in the Spinata circle, but they can't be in the Ripple circle. How many people like anything but Boone's Farm? So Boone's Farm, this whole circle is null. So it's everything outside the circle. 2, 3. See how that is? Pretty easy. It's just look at the regions, cover this part up. How many people like only Ripple? Got it. See how it's right there for us. Only Ripple? Nope. Nobody only likes Ripple. The Ripple people also like something else. How many like exactly 2 kinds of wine? It's a little bit more complicated, but what we're looking at is this one, and this region. Those are the ones that like 2 wines. Exactly 2 kinds of wine. Now these people in the middle like 2 kinds, but they like 3 kinds. But only 2 kinds would be 3, 5, 6. 6 people. So you see how doing a Venn diagram help us take all this different information and not count things twice, make sure everything's counted 1, but be able to answer some additional questions. And that's what the benefit of a Venn diagram is. It visually lays everything out. What you'll see is if you could kind of follow that, go to the center, to the ones that have 2, and then the ones that have 1, and then the ones that have none will be the leftovers, right? You'll be able to do the same with this 80 sophomores who are taking either English, political science, or history. Same type of thing. Remember, start with the center region. Those who are taking all three, work your way out. It'll go much smoother than if you try to work from the outside in. Now you could, there's 80, so you could start with that 80 and then start subtracting, but you'll be doing a lot of erasing as you go. You start from the center and do the subtraction. It's so much nicer. Take this from somebody who did it the wrong way for many years, and then somebody said, no, it's easier this way. I didn't believe them. And then I did it. I said, wow, yeah, because I had been doing it. That's how I was taught. Work from the outside in. It was the wrong way to do it. So not the wrong way, just the hard way. And then 3 will be the same thing, but it's got early peaches, late peaches, and extra late peaches. So 3 types of peaches. They give you some information. Again, just complete the Venn diagram. You'll be able to answer these questions. So you'll get 2 examples of working through it. If you want to do the online one, there's a similar type thing on the online one that you could do. But again, either or both if you want. But all you have to do is complete these 2. Do a few of the ones that we talked about. You'll have this packet complete. There's 30 points. Chapter 7's done. If you've already done Chapter 7, maybe I'll give you extra credit too. So if you want to do them both, so actually get up to 6% extra credit if you wanted to. So you do this, you do the online, you do all of them. And remember, 1 gets dropped, so you get up to 6% extra credit. You got that project, the 20%. Again, doesn't have to be done right away, but sometime over the semester. That's replaced 20% on one of the exams or both of the exams. And then we still have that final exam to go through. So everybody is still in good shape. You can make up anything from the past that you didn't have finished from 1 through 6. The only thing I ask you is to stay on track with 7 through 12. Those who struggled a bit on the exam typically hadn't completed some of the work or maybe were rushed to the work. So try to stay on track with things. It makes things go smoother. Any questions? Okay, so we'll end it here. I'll stop the recording.